We're talking about parabolas today. All right, so a parabola is a set of points in a plane that are equidistant. Means equal distance. Just trying to be fancy. From a fixed point called the focus and a fixed line called the directrix. Okay, so we're going to draw a picture, kind of like every time we do a new conic section, we're just going to draw a picture next to it. So we're going to have all these terms, and then hopefully we'll be able to kind of define them as we go. So I guess for now, let's just draw a parabola. Okay, so here's our parabola. The first term we're going to define in relation to the parabola is a vertex. Okay, so the vertex is the point halfway between the focus and the directrix. Okay, so on this, here is our vertex, which is also H comma K. All right, let's define the focus. So the focus is a point inside of the parabola. Okay, so when we label the focus, we're going to label it with an asterisk. And we'll also label it F. Okay? Then there's the axis of symmetry. Okay, so this one you know, right? Axis of symmetry is just the line that goes through the focus and the vertex. And this line is also perpendicular to the directrix. Right now this is just like a lot of terms and they don't make any sense. Once we kind of put all this together, you'll see it, okay? So remember there's that line that runs through the parabola. This is the axis of symmetry. This is the line that if you were to fold a parabola over onto itself, right, this would map onto itself over that line. Okay. Ready for the next one? Yeah, Lauren? Yeah. Thank you. Okay, so let's define the directrix now. Okay, so the directrix is a fixed line. It can be horizontal or vertical, depending on the parabola. And the parabola opens away from it. Okay, so here would be our directrix, down here. So in this case, it would be horizontal. Okay, if our parabola was horizontal, then our directrix would be vertical. Okay, then there is this distance P. Okay, P is the distance from the focus to the directrix, or I'm sorry, to the vertex, and the directrix. up to the vertex.
We learned most of this.
Yeah, you learned all of these terms last year. The only thing you guys didn't do last year was move the origin off, or move the vertex off the origin. Okay, so looking at this, going back here, so the directrix has to be perpendicular to the axis of symmetry. We didn't label that in our picture. And then here, this is a distance of P, and from the vertex to the directrix is a distance of P. Okay, so everybody okay with the definitions? Any questions about the definitions or the picture? Yeah.
So, like, the directrix doesn't touch the parabola?
Correct. Correct. All right. So now we have to talk about the equations. So this is the standard form of the equation of the parabola. Okay, so we have two cases. We have x minus h squared equals plus or minus 4p times y minus k.
It's plus or minus, right?
Okay, plus or minus 4p. Or you could have y minus k squared equals plus or minus 4p times x minus h. Okay, now I want you to think about this. So there's really two scenarios here. You're either going to have a horizontal parabola or you're going to have a vertical one. Which one do you think is vertical?
Y. The X.
I've heard y and x, which I don't know which either one of those things mean.
Y.
So vertical is like the one we're used to, right? Doesn't that look like y equals x squared? So doesn't it have to be the one with the x squared term? Where the y squared term would make it horizontal. Okay, so this equation represents either an upward or a downward pointing parabola. When 4p is positive, it points upward, and when 4p is negative, it points downward. Okay, so this is the parabola we're used to dealing with right now, okay, up to this point. Now, when you have a y squared term, this is going to be a horizontal parabola. All the pieces are still true. There's still the focus, directrix, distance of p, all of that stuff. It's just the parabola points sideways. This would be in the case of a negative 4p, and then it would point to the right in the case of a positive 4p. You have to memorize these formulas. Okay, how are we doing so far? Any questions? I don't know how, but I left off a ton of definitions.
Huh?
Yeah, I left off some definitions. We gotta go. Just one. We can squeeze it in though. Hopefully you can too. Put it on the side if not. Okay, here, this is one more definition I forgot to talk about. Ready? Not really. It's called the lattice rectum.
That doesn't even sound like math.
It's just stupid. It's just a stupid name that I think they made up to torture teachers. Who wants to say that? Okay, so we're going to call it, though, the LR, because it just sounds better. Okay? So we're going to talk about the LR. It is a focal chord which is perpendicular to the axis of symmetry and, this is the important part, has a length of 4p. So that's really the part we need to know, okay, is that the LR is equal to 4p. Okay, so if you were to look at this, all a chord is it's like a segment that goes through the parabola that connects the two sides. The lattice rectum is a special one because it is perpendicular to the axis of symmetry and it goes through the focus. Okay, so it's just a special one. Focal, not vocal, but focal.
Like focal point?
Okay, so this has a distance of 4p, and that's the part you need to know because it helps us to solve. Okay? Okay,
What did you put? I'm sorry.
I just labeled it 4p.
Okay.
Okay? Okay, so can we try some examples? Are we ready? Those are all the definitions. Okay? All right.
Are these examples that have a lot of space?
Do they have a lot of space?
This one's probably gonna, yeah, a little bit. I just turned the page. Just turn the page. Yes?
Okay, because if it don't connect,
Sorry.
I know, but I'm like,
All right, example 1.
example one.
How's it feel? How's it feel? How's it feel? How's it feel in your heart?
That's a great question. Okay, look at, we're going to write this in standard form, and then after we do that, we're going to find the vertex, the focus, the directrix, the axis of symmetry. I knew it was coming. And we're going to sketch.
No, just hurry. Hurry.
We're having a good day, huh?
Okay.
Did you get your start, but you still didn't.
Didn't get it. Didn't get it.
That's why she won.
Number 5 for you.
Okay. So this is what we're given. Okay, now the first part says to write this in standard form. But do you notice that it's already in standard form in this case?
Yeah.
Right? So we don't have to do that. That part's done. Okay? So now we have to find all the information. So we have to find the vertex, the focus, the directrix, and the axis of symmetry. And then we're going to sketch it in a second. Okay? So looking at this, remember that in order to find the vertex, it's the opposite, right, of what you see, because it's H and K that are going in. But here, we have a -4 and a -1. But the vertex is really 4, 1. Okay? Now, the next thing you should do is you should think about what does this parabola look like? Is it vertical? Does it point up or down? Is it horizontal? Does it point left or right? So we're going to look at just the equation right now. Okay, so we're not looking at anything else. We're just looking at this piece here. First of all, is it vertical or horizontal? Vertical because we have an x squared term. Okay, so it's definitely vertical, so I'm going to make myself a note. Okay, now I want to think about, does it point up or does it point down?
Down.
Down because we have a -4p. So this is points down, and then I might just make myself a note here because of the -4p. Okay?
Wait, which part of the equation is the -4p?
The one in front of the second set of parentheses. Okay? So now, right now, I'm just going to do a quick little sketch so I can see what's going on. So I have 4, 1 for my vertex, and I know that it points up. Nope, I lied. It points down. Okay, it points downward. So now I want to think about how do I know where the focus, the directrix, the axis of symmetry, can I find any of those pieces based on what I know right this second? Can you find the axis of symmetry right now? Right? If you know the vertex, then you know the axis of symmetry. So this is the axis of symmetry, and it is at x equals 4. Okay, so I know that piece. What I need to do now is find the focus in the directrix, and in order to do that, you have to know what P is. But I can get there, right? Because I know that this, -16, represents a -4p. So I'm going to take -16, and I'm going to set it equal to -4p. And everybody agree that P is 4 then?
Yeah.
Okay, so now I know P. So go back to your definition of a focus in a directrix. It says that P is the distance from the vertex to the focus and the vertex to the directrix. So can I find both of them now, essentially by just counting?
Yeah.
Right? So if I count down, I'll find the focus. So from 1 down 4 is going to give me a -3. Agree with that? And doesn't the x-coordinate have to be the same as the axis of symmetry? So the focus should be at 4, -3. Okay? And this is our focus.
Can you redo it out?
Yep. So I went from the vertex, and I knew that the focus had to be inside the parabola a distance of p. And I know p is 4, so from 1 down 4 would take me to -3. Okay, now the directrix has to go in the opposite direction, away from the parabola, right? So I'm going to count up this time by 4. And when I do that, I have a horizontal line here, right? Because it has to be opposite. It has to be perpendicular to the axis of symmetry, and it has to have the parabola opening away from it. So that's going to put this at what?
4, 5.
So at 5, but it's not a point anymore, it's a line. So how do you write an equation for a horizontal line? Y equals. So it should be a y equals 5.
So that's the same
So this is a distance of p, and this is a distance of p. So in our case, that's a distance of 4. Now, in terms of a sketch, if you gave me this, I would be happy. You're noticing it's not fancy, okay? If I want it fancier, I'll provide you with a graph. Yes? So I had to count a distance of p up, because it has to be away from the parabola. I was at 1. If I add 4, I'm at 5. And it's a horizontal line, so it has to be a y equals. Okay? It's not too bad, right? Okay, so that was best case scenario. You have to find the information, but you're already in standard form to begin with. That's not always going to be the case, okay? So now we'll talk about example B.
Is that how you would like a labeled
A labeled graph. That'd be fine with me. Okay? In your homework, that'll be fine. If I provide graph paper, I want it more, fancy. So 4x minus y squared minus 2y, minus 33 equals 0. Okay, now, the first thing we're going to do is we are going to decide whether this is vertical or horizontal. We're going to decide which term is our squared term. So y. So we know this is going to be horizontal. We're not sure which direction it's going to point yet, but we at least know that's a good place to start. Okay? I don't want to work with a negative y squared. So I'm going to move my y terms to the right side. Okay? So I'm going to have 4x minus 33 equals y squared plus 2y. I have to get this to look like y minus k squared equals plus or minus 4p times x minus h. That is the goal. What am I going to have to do to get there? You're going to have to complete the square. Now the good news today is you only have to complete the square once instead of twice. So, see, looking up already. Now, how do you complete the square? We already have a coefficient of 1. What do we have to do first? Take half of 2. So plus a 1 squared here. Now I factored out nothing, so that really means I'm just adding a 1 squared. So if I add a 1 on the right, what do I have to do on the left? Add a 1. So I'm going to put a plus 1 here. Okay, so now I'm going to combine these. I get 4x minus 32 equals, and I'm going to factor this. So y plus 1 squared. Okay, I'm getting close. I want my y squared term on the left, so I'm just going to flip-flop the sides. So I have y plus 1 squared equals 4x minus 32. Okay, I'm getting really close now. What do you think I have to do now? I got to factor out this 4. See, I have to have a number outside of the binomial, so I need a coefficient of 1 here. So I'm going to factor out the 4, and that's going to give me 4 times x minus 8. Okay, so here's my standard form. That was the additional piece that we had to do than example A, right? Example A came like this. We had to put example B into this. So now I can find all the information like I just did. So what is the vertex? Now listen to me. You're going to mess this up if you're not careful. You got to make sure when you're labeling the vertex, you're labeling X, comma, Y, right? Notice that Y is listed first. So be careful not to write -1, 8. Everybody agree it's 8, -1?
Yeah.
Okay, so just be careful on that. That's a common mistake.
Oh,
Right. So if you know the vertex, you know the axis of symmetry, right? Now, let's think about this though. What kind of parabola is this? Does it point left, right, up, down? Everybody agree it points to the right because it's sideways, right? It's horizontal and it's a positive 4p, so it's got to point to the right. So right now, let's start making our sketch. So we have a vertex at 8, -1, let's say. Looks like this. And it's got to open to the right. So when I go to think about my axis of symmetry now, is it an x equals equation anymore? No. Doesn't it now have to be a y equals equation? Because now it's a horizontal line. So you always want to start with your sketch before you start finding the other information. So everyone agree that the axis of symmetry would be y equals -1. Okay. Next part we have to find is the focus and the directrix. So in order to find the focus and the directrix, I first need to find P. Am I going to set 4 equal to a positive 4P or a negative 4P? Positive. So 4P equals 4, so therefore P has to equal 1. So now I have to count 1 in to the parabola, right, to find the focus, and that would place it at 9, -1. And the directrix has to be 1 outside of the parabola. Is it going to be an x equals or a y equals?
X equals.
Good, because it's vertical this time. Okay, so here we're at x equals, what, 7? We should label this y equals -1. This was 8, -1, and this is the focus. Okay? The only other thing I have to find, did I find it all? Oh, perfect, done. Okay, so let's go back. Were you okay with this? Okay, were you okay with the vertex? All right. Did you understand why it was horizontal and pointed to the right?
Yeah.
Okay, so then at that point, I could think about the axis of symmetry, right? It's got to go through the vertex, but it's a horizontal line this time. So that's why it's a y equals equation, okay? And then you had to find P. So I know I can see this as a positive. So when I set this equal to 4P, right, because that's what this equation looks like, is a 4P here. So when I set that equal, I choose the positive to set it equal to. So P is a distance of 1. That means from here to the focus is a distance of 1, and from here to the directrix it's a distance of 1. So I just counted. So to go from 8, 1, -1, and go over to the right 1 would take me to the point 9, 1, and that's my focus. And then the directrix has to go backwards. So that's why that's at x equals 7. Okay? Okay, now we're going to go backwards. So now I'm going to give you the information, and we're going to write the equation, which happens to be easier and quicker. At least 1,000,000 minutes. Probably we all will be.
Morgan Wojcik, I know you're going to watch this, so I just want to say hi.
Hi, Morgan.
Wait, I got so much space left for a wait.
Sure. All right, here we go. Example 2. Write the equation in standard form.
No, really.
Okay. Let's say I told you that the vertex was at 1, 4, and it had a directrix of x equals 3. Okay. Okay, so now, what do you think we should do first?
Sketch it.
Sketch a picture, because that's how we're going to really be able to see where to start. Got to sketch a picture. So, 1, 4. With a directrix of x equals 3. So, remember the directrix is a line, and in this case it's a vertical line.
Is the directrix at the butt or
That way. What?
Like, is it the front or the back?
The parabola opens away. The parabola has to open away from the directrix. Okay? So doesn't that mean then that the parabola has to open to the left? Okay, so this is a good start. So that means you have to have a y squared term, right? Because it has to open away from the directrix. Like it can't touch the
it's
directrix.
at the butt?
It is at the butt.
However you want to think about it. So y minus k squared equals, is it going to be a negative or a positive 4p?
Negative.
Negative 4p times x minus h. So that's the format I'm trying to go for. What else do I know? What can I plug in? Go ahead, Shemaya.
Vertex numbers is X
You know the vertex.
minus 1. What?
Don't worry about it, Dave. Keep going. Keep going.
That's what I'm talking about.
I called on Shemaya, and but you jumped the gun, so it's fine.
Quiet, Shemaya. Whatever, y minus 4,
Yes.
and then the square equals negative 4p, x minus 1.
Good. Okay, so I know the vertex, so I can plug in h and k. How am I going to find p? Go ahead, Colin.
Since we just...
Wow.
Alright, I'm calling it.
That's correct. So this distance right here is p, isn't it?
Yes.
So from 1 to 3 is a distance of 2. So p has to be 2. So I'm going to plug that in, and then I have to multiply those. So final answer should be y minus 4 squared equals negative 8 times x minus 1. Yeah, it's easy, and it doesn't take a long time. Now, what if I gave you a vertex of 0, 0 and a focus of 0, negative 3?
What if you did? I don't really know. Is that like a good
Mm-mm.
No.
Oh my god.
No, this is not the last example. Shh. What should you do first? Sketch. So 0, 0 is our vertex. We have a focus is 0, negative 3.
That need to open down.
That does mean it opens down
Man.
because the focus has to be inside, right?
parabola down? Vertex.
So we have x minus h squared equals positive or negative 4p?
Negative.
Negative 4p times y minus k. Do you know the vertex? Yep, so we can plug in 0 and 0. Do you know p? How? Right, so this distance from the vertex to the focus is p, and that is 3. So now we're going to multiply this by 3. So the final answer is going to be x squared equals negative 12 times y. You're not going to write in the zeros, okay? All right, now you're going to try one. Oh, I'm sorry. I'm sorry. What's your question? Yes. Yes. Okay, now try this one. So the focus is going to be at -1, -3, and the directrix is going to be at y equals 1.
You're doing a class? I know, she just made my head hurt. I can't go.
Where the Vertex at, bro?
I'm gonna just wait till you do
It's your birthday, so
Let's try to stay focused on this
It's
problem.
Friday. We ain't staying focused.
It's
it.
your
Oh,
name.
Miss Green gave a look.
Shit, I.
remember there's the most
So -1, -3. You have a focus at, right?
Wait, I'm not.
Wait, we're not done yet, please.
Okay.
Vertex is a 0 here.
Wait, so Miss Green,
0 negative.
That's the point of the line.
Thank you.
Miss Green,
Do you see that too?
the directrix and the focus, can they change which direction they go?
Yeah, they can change direction. Where does the vertex have to be?
Halfway,
Has to be halfway between here, doesn't it?
the directrix and the focus.
So doesn't it have to be right here? At -1, -1. Because it has to be on the same axis of symmetry, right? Like the focus is. So we know the x-coordinate has to be the same, and it has to be equidistant between the directrix and the focus. So what is the distance of P then? 2. Is it an x squared or a y squared? It's an x squared. Is it a positive P or negative 4P or a positive 4P? Negative, because it's pointing downward. So final answer should be x plus 1 squared equals -8 times y plus 1.
Yeah, I don't get this.
I don't get that one. That one I don't get.
Okay, so do you understand that the vertex has to be halfway between those two?
Yes.
And it has to lie on the same line.
The
Yes.
same line as to what? That's what I'm not understanding.
So the axis of symmetry goes through the vertex and it goes through the focus. Okay, so it's got to be the same x-coordinate. That's how you knew that. And this distance total is a 4. Half of it would be 2. So that's how I knew P was 2, and I just counted either way a distance of 2 to figure out that vertex was -1, -1. Okay? I can't really do any more with you today. So, we're done.